Okay. Good morning. Fluid mechanics, very important topic. Pressure, right? So, pressure will have a very good definition, right? But people usually saying that pressure is nothing but force acting on area or force by area. Yes, it is also a one definition, and one more definition. It is a normal stress, right? It is a normal stress. The example, say for example, pressure, where the pressure is developing, right? In our day-to-day life, the very best example is pressure cooker, right? Pressure cooker is best example, right? Due to pressure only we can hear the sound from the cooker, right? So there force acting on area is the first definition. Second definition, it is a normal stress. What is normal stress, right? So if you take a pressure cooker, right? So it is a closed one, it is a closed vessel, right? So when you supply heat from the stove, right? So inside your cooker there will be some water, and if you want to boil the rice, you will filled with rice, right? So you have filled already with rice and water, right? So when you supply the heat, the temperature, right, and the pressure is increasing. We are saying like that, right? What is pressure? Here also, what is pressure? It is a normal stress. Normal is nothing but perpendicular. Normal is perpendicular. Stress is nothing but an opposing force. Stress is nothing but opposing force. Stress is nothing but opposing force, right? So when you supply a heat a perpendicular direction, right? So perpendicular means, so this is your surface of the cooker, which is going to affect because of pressure and temperature, because through this only your sound will come, through this surface only sound will come. So fluid is feeling like this. The stress or the force acting in this direction is perpendicular to the surface of your cooker. That's why here we are using the normal word, the word called normal, right? And then opposing force, which one is going to oppose? So this closed surface is going to oppose. Your force is applying this direction, your force is coming from the fluid, whatever the fluid or something, rice filled inside the water. So this is your force. So the opposing direction is from the surface. So this is your stress, right? So we are saying this is your pressure. So this is nothing but pressure. So pressure is acting on the surface of the cooker, right? So this is the best definition. Normal stress is nothing but pressure. So what kind of normal stress? The next question is, what kind of normal stress is it? There are two normal stress. One is tensile, right? If you take solid mechanics, tensile, and second one is compressive. Always in fluid mechanics, compressive stress only acting. But we never ever use the word compressive stress again and again in each and every topic of the fluid mechanics. We are using only the word pressure, right? The meaning of pressure is normal stress. One more example. So if you take a vessel and filled with the water, so water is in static condition, right? It is not moving, it is at rest. So the weight of the water is acting. Where it is acting? The bottom surface of the vessel. The bottom surface is facing the direction of the weight is. That means the whole weight is acting perpendicular to the surface of your vessel, right? So that is the weight or force acting on the surface. The surface is withstanding or opposing for carrying that water. Opposing force is generating by the surface. That force is nothing but normal, that force, opposing force is normal stress or pressure. Normal stress or pressure. So in fluid mechanics we are always using the word pressure. We never ever used normal stress or else compressive stress, right? So thank you. Compressive stress and normal stress both are same, because normal stress is classified in two ways, tensile and compressive, but fluid mechanics we are using compressive stress alone, right? So this is, I think this is understandable, the meaning of pressure. Thank you so much.